In this lesson, we're going to look at rounding, and we're going to round to a nearest whole number, to a nearest decimal place, and to a nearest significant figure. They're all very similar, so let's get started. So first of all, to the nearest whole number, or even power of 10. Now, if we look at the first example, 2,851, what you're really asking yourself is it closer to 2,000 or is it closer to 3,000? And of course the answer is 3,000. Now I wouldn't go into any more detail than that. Keep thinking in those terms and you're going to get these correct. In the second example, what is it to the nearest 100? So think about where it lies on the number line. Is it closer to 2,800 or 2,900? And of course 51 is just going to be closer to 2,900. So that is the answer there. And the final example on this page, what is it to the nearest 10? Well, think of the tens, think of the number line. Is it closer to 2,850 or 2,860? And of course it is 2,850. So don't overcomplicate this. Think about it in terms of the number line and in terms of what it's asking you to round to, and you will find the questions very, very simple. What about some of these more challenging ones? Around 1.8029 to the nearest whole number. So if it's a whole number, then surely the only answer could possibly be 1 or 2, because the number is between those two values. And of course 1.8 is nearer to 2, so the answer is 2. Now, let's get into some more details now about this. We're now looking at decimal places. So 1.8029 to one decimal place, we are allowed to consider the number line 1.8 and 1.9, and this question is somewhere there. So it's the same principle. You're asking yourself, is it closer to 1.8 or 1.9? So the answer is, of course, this one, 1.8. 1.80, the 0 is the important part here. This is telling me that we're near to 1.8. If it was 1.87, then we'd be closer to 1.9. In actual fact, there's some rules we need to think about now. If that second number there was a 0, a 1, a 2, a 3, or a 4, then certainly we're going to go and round down, in this case to 1.8. But if that second number after the decimal place had been a 5, a 6, a 7, an 8, or a 9, it would have been closer to 1.9 and we would have rounded up. So let's have a quick look at the last example on this page, 1.8029 to 2 decimal places. Well, we're thinking about, if we look at the number, the answer's got to be either 1.80 or 1.81. Those are the only two possibilities because this number falls between them. So which one is it closer to? Well, in this particular case, the key number is the 2, isn't it? The 2 is low. It's closer. It's a 0, 1, 2, 3, or 4 like we discussed in the previous example. So we're going to round down again, and therefore the answer is 1.80. Now we need to move on to significant figures, and this can be quite confusing. This is another way to round, particularly dealing with very, very big or very, very small numbers where decimal places or whole numbers or powers of 10 just isn't useful. Now, on this page, all of the numbers have been rounded to 3 significant figures, and I'm hoping you're going to be able to see a pattern going on here. If you notice, there are 3 numbers that are either non-zero or are used as sort of markers for what that number is, and everything else has disappeared. Now, I'll be replaced by zeros, and those further zeros, they're just place value holders. Now, the example pointed out and highlighted is very interesting. It has been rounded to 3 significant figures, but you could argue, depending on what the previous question was, it looked like it had rounded to only 2 significant figures. But sometimes this can happen depending on the values you're given. It just means that one of those zeros is a significant figure. Okay, so let's have a look at how this might look in practice. So, if you're asked to round to 3 significant figures, you are really emphasizing the most important values on the left that give the value its size. So, that's going to be, in this case, 294,000. That is 294,394 rounded to 3 significant figures. Let's have a look at the next one. Well, you might be expecting the answer to be 974,000, but that is wrong. That is not correct. Let's have another look. 9 and 7 are definitely correct, but if we look, is this closer to 9,740,000 or 9,750,000? And because of that 9 there, we need to round up. So just like the rules for decimal places and for whole numbers and powers of 10, the answer needs to be rounded up. There we are. Okay. Now, we can do this with very, very small numbers as well. We've been writing zeros for numbers on the right, but it can also happen for numbers on the left. Now, if we look at this example, 0.004 is the correct answer. The numbers on the left are just markers. They're place value holders with no designated number inside. But the first number we need to talk about is in the case of the question, the 3 in the 39842. But because of that 9, we need to round it up to 4. Now, we don't need to write zeros in place after that at all. The way we write numbers and our traditional way of writing them means that we just simply wouldn't bother. This final example here is going to be quite challenging for me to count, but it's going to be 0.000000093, and of course that last number is going to be 3, because that 9 will round that 2 up to being that 3. Okay, that is everything you need to access the next exercise. Good luck.